Hi, today we are explaining basics of 7-segment display. This includes everything which you need to know to start working on 7-segment display. And later we will also design a BCD to 7-segment display decoder in VHDL. So these are the topics which we are covering today. We will start from the quick basics of 7-segment display, how 7-segment display works, and then we will talk about types of 7-segment display. We will discuss pin description of 7-segment displays, and we will talk about common anode type of display and common cathode type of display. In next step, we will understand the mapping between BCD input and 7-segment display output. This is the most important to learn for 7-segment display drivers. Next will be VHDL coding for BCD to 7-segment display decoder. Later, I will brief you how you can design a decimal counter which will count from 0 to 9 and display that on 7-segment display. Next would be a small introduction to 7-segment display multiplexing technique. Okay, so let's start. So this is how a basic 7-segment display looks like that you can purchase from the market. In the market, these can be available in different sizes or designs, but the basic fundamental is same. I'm sure you must see them in many appliances in your day-to-day life because these are very common for number displays. Okay, let's talk about the design first. So there are 7 LEDs packed in one structure in such a way that they can display or illuminate 0 to 9 digits. Because there are 7 LEDs, that is why we call them 7-segment display. Like here, we have LED A, LED B, LED C, LED D, LED E, LED F, LED G. Each LED called LED segment. We have this one more LED for decimal point as well. So before you start, you must know that LED will only glow when the current flows in the right direction. In case of reverse order or wrong polarity, LED will not glow. So look over this truth table for this simple circuit. When A is high and B is low, then only red LED will glow. Green LED will not glow at this time. Same way, when B is high and A is low, then only green LED will glow. Red LED will not glow in this case. For all the other scenarios, both the LED will off. We just need to remember the basic function of LEDs. We are not going deeper on the LED fundamentals in this video. Now let's talk about the LEDs inside the 7-segment. So this is the package and the structure look like this. Now assume from this display we wanted to display 0 first. So how you will display that? Simple. Switch on all the LEDs in this package except this middle one. And this package will illuminate 0. Now suppose we wanted to display digit 1. Then LED B and LED C need to glow and all other LEDs should off. Right? So LED B and C is on and it display 1. Same way, you can illuminate or display all the numbers from 0 to 9 on the 7-segment display just by controlling which LED should glow and which LED should not glow. Check the number 8. All 7 LEDs will glow for 8. Check digit 6 and digit 9. For digit 6, only LED B will not glow, and for digit 9, only LED E will not glow. Easy, right? As I said, LED can only glow when the right polarity is applied. Wrong polarity or reverse connection will not glow the LED. And considering this, we have two basic types of 7-segment displays in the market. One is called common anode type display and second is common cathode type display. These both type of display looks exactly same package, same design, but just reversed in polarity. So you cannot identify them just by the look. As its name suggests, one terminal of all the LEDs inside the package interconnects with each other and this pin will be common for all the LEDs. If all the anode pins are connected, then we will say this is common anode type 7-segment display. But if the cathode pin is interconnected inside the package, then we will say it's common cathode type of 7-segment display. To identify that which type of 7-segment display you are using, you can connect the common terminal to plus VCC and connect the another terminal of LED to the ground. So if LED glows, then it is common anode type of display. But if it is not glowing, then connect the common pin to the ground now and connect the another terminal of LED to plus VCC. If LED glows now, that means you have common cathode type of display. Once you know which type of 7-segment display you have, connect the common pin to either plus VCC or ground. So common anode connect to VCC and common cathode connect to ground. And we will control all the LEDs with the another terminal. Let's take the example on the screen. So left screen used common anode type display. So common pin connected to plus VCC, and our decoder output must be logical low to glow specific LED. So if any pin is high, then that specific LED will not glow because of LED basic function. So simple thumb rule is common anode type display drive 0 or logical low to glow the LED. Same way, right picture is for common cathode type of display. So common pin is connected to ground. This means to glow the specific LED, that specific pin should have logical high or digital 1. So simple thumb rule for common cathode type of display. So logical 1 will glow the LED. So quickly go through these two screenshots. So these are our LED terminals. So in case of common anode, all the anode terminals will adjoint and we need to connect it to plus VCC of circuit, and you need to use logical low to drive or illuminate any specific LED in this package. In case of common cathode, all the cathode terminals will adjoint and we will need to connect it to the ground of circuit, and you need to use logical high to drive or illuminate any specific LED of this 7-segment package. So this is just a brief. We will talk on this sometime later when we actually code our BCD to 7-segment display decoder. But in general, we prefer to use common anode type 7-segment display because that syncs the current from positive terminal to the chip or IC. On the other hand, common cathode type 7-segment display actually sources the current from the IC, which affect many attributes of the IC, including the heat factor. As I said, we prefer to use common anode type of 7-segment display widely. So one terminal is common, which is anode, and that is connected to plus VCC. So in order to glow any specific LED or segment, we need to pass digital low or digital 0 at that pin, and pass high or digital 1 if you don't need to glow. You can see in this image that how these signals from E to G is driving the 7-segment display to illuminate digits. You can see these values here which are passing to 7-segment display. So it's time to try this small exercise. Map the output of 7-segment LED for each digit from 0 to 9, because later in this video you will need this mapping. So let me explain this task with one example. So assume we want our 7-segment display to illuminate digit 0. So the first column would be the decimal digit, which we consider 0 in example. And then second column is for the input lines, which would be the binary conversion of decimal. So here it is 0000. This would be the input of our decoder. Now our output lines will be the driver for the 7-segment display, which will tell which LED should glow and which LED should not glow to display that specific input digit. Simple, right? So this means for input 0000, the decimal value is 0. All the LEDs except this center LED should glow. This means for common anode type 7-segment display, all the terminals should low or digital 0 except this signal G, which is driver to center LED. So very important to remember the name of LED which you are mapping. So this is A, this is B, this is C, this is D, this is E, this is F, and last this is G. Similarly for digit 1, LED B and LED C will be logical low and all other pins will be logical high. So your output will be 1 0 0 1 1 1 1. So you can pause here to complete this task. It would hardly take 1 or 2 minutes. If you already completed this task, then you can map your results with this. If not, then let's quickly fill this table. Note that we are using common anode type of 7-segment display. This means logical 0 will glow that specific LED. Okay, so first is 0. So for 0, this, and this will glow. But G will not glow, so that means it should be 1. All other bits are 0. Now for 1, this is glow, this will glow, so B and C will glow, and all other bits will be 1. Now for 2, so this this, this, this and this will glow. So F and C will not glow. F and C will not glow. All other bits will 0. Now it's turn for 3. So for 3, this and this will glow. So only E and F will not glow. So E and F will not glow. All other bits will glow. Now 4, this will glow. So A, D and E will not glow. So A, D and E will not glow. All other bits will be 0. Now for 5, this and this. So B and E will not glow. So B and E will not glow. All other bits will be 0. So it's 5. Now it's turn for 6. So for 6, B will not glow. So only B will not glow. All other bits will be 0. Now for 7, so this is our 7. So E, B and C will glow. So A, B, C will glow. All other bits will be 1. Now for 8, all LEDs will glow. All will be 0. Now for 9, this E will not glow. So E will not glow. All other bits will glow. That means we will set 0. And that's it. Same way, if you are using common cathode type of 7-segment display, then refer to this table. This is simply the inversion of our last table which we mapped in last slide. That means logical 1 or high will drive the LED and 0 will not drive the relative LED. You can give a pause here if you wanted to review this table. Next, we will be jumping to our today project, which is design of a BCD to 7-segment decoder using VHDL. So this is our today project. We are making a BCD to 7-segment display decoder which will convert the BCD inputs and will give us the output to drive the 7-segment display LEDs. So what this decoder will do? So this decoder will take the BCD input of decimal value, which is 4-bit in length, and will convert this into the relevant signals to display the same decimal number onto the 7-segment display package. I already explained this in last few slides. So this is our behavior function. We are making this with the help of with select function in VHDL. You can choose any method which you prefer for VHDL designs. Like you can use if-else statement or you can use case statements. This table is for common cathode type 7-segment display. So digital 1 will drive the LED. Note that in the slide we are only explaining the behavior of our function now. We will be writing our full code sometime later in the practical exercise. So this is our VHDL code using with select function. So write with BCD select. So BCD is our input type signal in VHDL for this module, which would be vector type signal and 4-bit in length. Dout underscore 7seg would be our output type signal for this module, and this would be 8-bit long. I have taken one extra bit for decimal point in the last. So Dout underscore 7seg gets a value of this when BCD would be 0000. Then comma, and then list the next mapping for digit 1, then for digit 2, then for digit 3, then for digit 4, then digit 5, then digit 6, then digit 7, then digit 8, then digit 9, and all zeros for invalid inputs. Same way you can write this decoder for common anode type 7-segment display. I just inverted the values which are driving the output Dout underscore 7seg. So logical 0 in last slide replaced by logical 1 now, and logical 1 in the last slide replaced by logical 0 now in the output of Dout underscore 7seg. Simple, right? So this is side-by-side mapping. Left one is for common cathode type display. Note that here digital 1 will illuminate the LED of 7-segment display. Right one is for common anode type display. Here digital 0 will illuminate the LED of 7-segment. You can pause here if wanted to review both the list in one screen. Here is a quick tip for you. So in case for one project you have common cathode type of 7-segment display, so you use this code for your decoder. Now you wanted to use common and type of 7 segment display for your some another project. Then you do not need to write the whole mapping again. Just create an internal signal and use that for this 7 segment display decoder output. But before moving it to the final output, just use a NOT gate before that. Here I did. So this mapping is for common cathode type display, which is driving internal signals named as INT, SIG, NAL int signal. And later I write Dout underscore sensec gets the value of NOT of INT signal. That's it. Your decoder is converted now from common cathode type display or common cathode type decoder to common anode type decoder by just adding this one line. Now it's time for a practical, and we are going to write a full VHDL design for this decoder, and then we will simulate it in the waveforms. Okay, so today we'll be using Xilinx Vivado. So we will click on this. So Vivado is opening now. Click on create project because we are creating a new project here. Okay, this is welcome window. Click on next. Give some project name. So type BCD underscore 7sec decoder. Click on next. So we are making an RTL project, so select it, click on next. Now you can add a file from here because we are not adding any file, so we will not do that. But we are creating a file, so we'll create a file. So file type is VHDL. Give file name BCD underscore 7sec 01. Click OK. So this is our VHDL file. This is named as BCD underscore 7sec01.vsd. Click on next. Make sure target language is VHDL and simulator language is VHDL because we are using VHDL language for our code. Click on next. So this is add constraint because we are not using any port, so we don't need to put it here right now. As we are not using any FPGA, so select any device, doesn't matter. So this is final summary. So this will create a RTL project. One source file will be added, and in the last some device details. Click on finish. Okay, so now we will give some basic information here. Now next is port declaration. So we will give BCD. This is input type and this is vector, so click on bus, and for this is 4 bits, so type 3 down to 0. Next output is Dout underscore 7sec, and this is output type signal, so select out. Again this is vector type, so click on bus, and this is 8-bit, so write 7 down to 0. Okay, so this file has been generated. So this is our entity name BCD underscore 7sec01. So this is behavior, our architecture, and this is VHDL file name. So we'll double click it, and this already created the structure for our VHDL code. So library declaration is here, entity declaration is here, and we have the architecture body, and we only need to write the behavior of our design now. So type with BCD select Dout underscore 7sec less than equals to double quotes 11111100 when 0000 comma 0110000 when 0001 comma 11011010 when 0010. Next 11110010 when 0011 comma now 0110010 when 0100 comma now 10110110 when 0101 comma 1011 1110 when 0111 sorry 0110 now 11100000 when 0111 comma now all 1 except last 0 when 1000 comma. Now 1111 0110 when 1001, comma, and last all zeros when others, and semicolon in the last. Okay, so we have completed our VHDL code. Now save this program or save this code. Okay, it is saved. Now from the Flow Navigator we have this simulation tab, so click on it. Now click on run simulation, then click on run behavior simulation. So it's running now. Okay, so this is our simulation window, and this is input BCD, and this is output 7sec. So BCD is 4-bit and the out is 8 bits. So let's force some value. So force constant. Now let's give 0000 first. So okay, now run this simulation for 10 nanosecond. So click on it. Okay, so we have the input 0000 decimal 0, and we have the output. So as I said, only central LED will be 0 or will not glow, and all other LEDs will glow. So it's 111100. Now change it to 0001 now. Okay, now we need to run it again. Click on this button. Now adjust this window. Okay, so the value is 0001, so we need to display 1 on the display. So only B and C is 1 and all other lines are 0. That means this is good. Now quickly give one more input. So now we wanted to display number 8. So give input 1 0 0 0. Okay, now we need to run it again for 10 nanoseconds. Adjust the window. Okay, so it's 1000. So this is BCD 8. So it's all 1 except the last one, because last one is for decimal point, but all other output pins are 1. That means all the LEDs will glow. So this is our simulation. Now you know how to drive 7-segment display from the BCD inputs. This was the first step. Now think a little bit about how you will design a counter which will display 0 to 9 number in increment order and changes every second. Let me give a quick small tip. Because you already designed BCD to 7-segment decoder, this means you only need to drive the BCD input. To design this, you can segregate your requirement in small functions. Here we are segregating it into 2 small functions. So the first step is tuning the clock frequency. So your FPGA board should have a clock frequency, but that won't have the 1 second of cycle which you need for your design. So first step is you need to know the clock frequency of your board, and then you need to adjust this clock frequency to set it to 1 Hz. So we need to design a frequency divider which will cut the board frequency down to 1 Hz. Now second step is you need to use that 1 Hz frequency to drive your BCD counter. And now third and final step is convert this BCD counter to 7-segment display output, which you have just designed in this video. So if you are already aware of counters and able to code them in VHDL, then you can try this design by your own. And do let me know if you designed and integrated it into the FPGA board, and give me a thumbs up. But if you are new to VHDL, then no worries, I will be covering all these topics later in this video series, and we will design this together. You only need to do one thing, that's subscribe to Learn and Grow community and follow us for the regular updates. Now, if you have the basic understanding about 7-segment display operation, then I wanted to give you a brief to one of the highly used technique for driving multiple 7-segment displays. This technique is called 7-segment display multiplexing, and this concept is very important to understand because this would be used in various designs. The reason is the decoder which you have designed in this video required 8 pins to drive one 7-segment display. And now suppose you are making a digital clock where you require 6 displays, and then you will be needing 6 by 8 total 48 pins from your IC, which is not a good idea to occupy that number of pins for that such a small requirement. So what you will do, if someone asks you to operate those 6 displays with lesser number of pins, then you can use this 7-segment display multiplexing technique for your project. So how this will be done? So first, we will interconnect all the data pins of all the 7 segment displays. And by doing this, all the 7 segment display will illuminate the same digit, and you will occupy only 8 pins for this. Now, the second step is to specify which 7 segment display illuminate the data at any specific point of time, because we do not want to display that same data on multiple 7 segments. So one data will illuminate on one 7 segment display at any specific point of time. Now the problem is that all the 7 segment displays illuminates correct digit, but only one 7 segment display glows at a time, and we do not want this. We wanted to see all the digits at once. So the question is how to fix this now. So the answer is we are not fixing that because we cannot actually fix, but instead we will use a cheat, and the cheat is only one display will illuminate at any specific point of time. This means first display will illuminate 1, and then second display will illuminate 2, then third display will illuminate 3, and then this fourth display will illuminate 4. So all these displays illuminate digits one by one, but that will happen at very high frequency. And by doing this, all the 7 segment displays are actually flicking, but because this is happening at very high cycle, human eyes will not be able to differentiate that, and it will illuminate like all the displays are live all the time, like magic. So I will leave you here so that you can think about this little and try to code this design with the 2-digit display. If you're done writing code for this, do let me know from the comment section. If you're struggling to design this, then no worries, because we would be designing this project in upcoming sessions. Meantime, do subscribe to Learn and Grow community, like this video and share this video with your connections. If you found this video helpful, please give it a like and leave a comment below, and don't forget to subscribe for regular updates.